In this video I'm going to demonstrate the most important improvement in MwPharm Release 1.4.1, and it's about a better integration of dialysis into the software. So we discriminate between two types of dialysis: hemodialysis, HD, and peritoneal dialysis, CAPD, or in short PD. So what's the difference between them? So with a hemodialysis there is a continuous flow of blood along a membrane where there can be an exchange, for instance, of drug, and then the blood returns to the venous system again. Whereas in peritoneal dialysis, you have a solution bag which you then enter in the peritoneum, where it stays for a while so that there can be an exchange of substances and drugs, and then it's taken out again using a drainage bag. So if you look at some typical values, so we have hemodialysis with a flow about 200 milliliters per minute, duration 3 to 4 hours, and interval time of 48 hours. While the peritoneal dialysis, CAPD, is a bag volume of 2 liters, so we talk about not a flow but a bag volume. The duration is about 6 hours, we call that dwell time, and an interval about 6 hours. So first I wanted to show you how we do this on the modeling level, because we had to add some new objects to the Adsim++ model designer. So what I can do is I can do an experiment. So what I normally would do is I would create a simple one compartment model, add an input, I add an output, normal elimination. If I simulate this, you get this type of pattern. So I want to make it less complex. I say, okay, I'll give one dose, simulate it, and you get this typical plasma profile. What I do now is I will change this elimination to an artificial elimination. And we start with a hemodialysis. And I will start, for instance, with a flow of 1.1 liter per hour, and I will start at 2 hours with a duration of 4 hours, interval time of 8 hours, and I will repeat it, let's say, 4 times. And if I now simulate this, you get this type of pattern. So initially nothing happens. This is the first period, the second period, the third, and the fourth period. So the efficiency of the extracorporeal elimination or clearance is determined by the extraction ratio. And if I look at here at the parameters, you see here the extraction ratio which defaults to 1. So if I make it smaller, like 0.5, then you got to remember that the effective clearance is this extraction ratio multiplied by the flow you specify here. So if I now simulate again, you see it's less effectively. So I can increase the flow by a factor of 2 to get the same result again. So this is the typical example of hemodialysis. Now the peritoneal dialysis. So I can simply change this object type to a peritoneal dialysis, and watch what's happening here. So now you can you can still enter a flow, a liter per hour, but if I now change it to a peritoneal dialysis object, it's now you can enter a bag volume. So let's say if I, for instance, would enter 1 liter bag volume, I have started 2 hours, I have a duration of 4 hours, an interval time of 8 hours, and again 4 times. So let me see, and if I simulate this, you get this type of pattern. So it looks a little bit like an extracorporeal or a hemodialysis. So what I can do now is I can also look in the concentration in the peritoneal fluid. So I go here to variables, and I click here on concentration. Now I simulate again. So you see here the concentration building up. So what you also see is that there is no equilibrium reached yet, because the exchange was too slow. So I can do two things. I can leave it in for a longer period of time, or I can increase the distribution clearance of this peritoneal dialysis. So if I go here to parameters, I see here the clearance. So it's the distribution clearance between the compartment and the peritoneal fluid, and I will simply increase it by the factor 10. So 1 liter per hour. And never simulate it again. Then you see that you get here equilibrium. Now it's fast enough to get equilibrium. And what you also see is that the concentration is about halved with each peritoneal dialysis period. And then I can explain that, because if I look at the volume of the central compartment here, it was set to 1 liter per minute. And you see that if I look at the bag size, is also 1 liter. So the amount of drug which was in the central compartment is redistributed over the peritoneal fluids. So half is then, and because it has the same volume, half is taken away, and this process is then repeated. Okay, so this is one way of doing it until now, but the thing is that this is not that useful, because the volume is typically a constant. It's typically, bag volume is typically 2 to 3 liters. What you like to change is the dose, because I can also add a dose through this. So let me show. So this is our situation. What I do now is I will remove the injection. Simulate this. I have nothing. And what I can here do is I have a constant called dose. And if I set it to, let's say, 100 milligram, and I simulate it, then you get the other way around. So now 100 milligram is added to the peritoneal fluid of the drug, and then it's going back into the central compartment again. But what we like to do is not to vary the volume here, but we like to vary the dose. So for that goal, we created a new input object. So let me copy this. Yeah, no, not necessary. But so I will delete this peritoneal dialysis output object, and we create a new input object called TI PERITONEAL. So there's an I in front of it. And what's special about this object is that you don't connect it the usual way, like this, like you connect all inputs, but you have to connect it like this. And then you see that you have a special input because there's a bidirectional arrow here. So, and now you see that I can enter here a dose, and under the constants I can enter the bag volume. So I'll leave it at 1, but you can typically change it to, let's say, 2 or 3 liters. I go back here. So, and I can say, okay, I will start here at 2 hours, 4 hours, and I do it 4 times again. So I give through the peritoneal route 100 milligrams, and I leave the peritoneal fluid in for 4 hours. It's like a kind of infusion time, an interval time of 8 hours, and I have 4 dosages, and then we get this. So you get the same type of curve. Now also here I can show you, of course, the concentration in the dialysate. So let's see, like here, and we get the same type of. You see that there's no equilibrium reached yet. So because here the clearance was set to the default value of 0.1, I will increase it again to 0.1. So and then we have the same curve again. So from a process point of view, these two, the T PERITONEAL output and the TI PERITONEAL input, are exactly the same. The only difference is that you can here then enter bag volumes and under a constant the dose, while here in the input object you can enter the dose and under constant the bag volume. But now we have another interesting possibility, and that is, so if I rename, I will throw away this one, and I will show you with a new model. So what I do is I add a normal elimination here, I clear this dosage regime, and I rename this input object to PD. And I can now go to a dose calculation. And I have to add a reference here, so add a reference. And I can do dose calculation. And you see that if I can select it here, the PD, the peritoneal dialysis, as a route of administration, and then I can do a dose calculation. And so that's really something new, which was not possible previously. Okay, so this is from a modeling point of view, but of course, it's if you have to do that for all models in MwPharm, it would be kind of complex. So we made this management of dialysis objects in MwPharm easier, and I'm going to show you right now. So here I'm in MwPharm, and I will load the patient test E. And if I now go to settings, you see a new, under model settings, you see a new section called dialysis settings. And here you can specify whether you want to have hemodialysis or peritoneal dialysis support. And you can also specify a relevant parameter. So you see here that by default there is a hemodialysis object and there's no peritoneal dialysis object. And if I look at the model, you see it's right there, the hemodialysis object. So what I can do now is I go here to the settings and I say, okay, I want to also have peritonealysis dialysis available, and I can select between output or input mode. So I just showed you this in the AdSim. So I will select typically for input. And now I can specify additional values, so the PD clearance, so make it higher, let's say 1 liter per hour, and the bag volume, I can change it, for instance, to 2 liters. So if I look at the model again, you see that this is now automatically, this input is automatically added. So what I can do now is I can, if I go to my history screen, and if I go look here at the route of administration, I can select. So I can select IV, IM, PD, and HD. So peritoneal analysis. So I can now, what I now can also do is I go to dosing, and now I will select here PD. And then you see here the dose calculated for the peritoneal route of administration. So if I click, say, let's say I want to have 4, and I move into the history, you see the PD route is added here, and if I simulate this, you see here the dialysis periods and the effect of adding drug this way. So, but it's important, of course, that you use the correct parameters, so that you have a correct value for extraction ratio in case of the hemodialysis, and that you have a correct value for the peritoneal clearance of the drug and the bag volume. But certainly this will make it much easier for you to manage the dialysis model for the patients you're going to calculate a dose for. This completes this video.